Okay, today I'm going to lecture about what I mean by behavioral research methods, measurement, statistics, and data science. That is actually an approach that uh, use software. It's not something that is based on some kind of theory or something that is not applicable. All of these approaches are based on software, so I would rather to name it software-based behavioral research methods, statistics, measurement, and data science. This is a plan actually that I'm uh, going to have for compiling a book about research methods that include some new approaches, uh, quantitative, qualitative, and mixed research method approaches that actually consider all of the modern methodologies, AI-based methods, machine learning methods, and all of these new approaches into the realm of psychological research, educational research, or in the vast field of behavioral research methods. So I'm going to refit this kind of design in three major domains of quantitative, qualitative, and research mixed method design. So all of these methods, measurements, data science is actually subjected to a branch of quantitative, for example, research methods. So it's not something different than quantitative research design. So I actually unified all of these methodologies together in three branches of quantitative methods, qualitative methods, and mixed research method design. So if I want to introduce you with some kind of quantitative methods, it's actually about in the field of quantitative research methods, it is actually split into two kinds of experimental and non-experimental research methods. It is something that generally is accepted in the field of research methods in behavioral sciences. But there are other variations for quantitative research methods that I have modified somehow in this hierarchy, and uh, I'm going to make some minor changes to some design and ignore some other designs because of the scarcity of use of some design, because of the developing new and actually complicated research methods. So in experimental design, I actually would introduce you with a software like SPSS that can do the analysis for you very easily. For example, a design, for example, suppose that uh, design with experimental and control group with a pre and post test and follow-up measures, and you may want to do analyze actually doing analysis of variance for repeated measures with these two control and experimental groups, and you may want to do the inferential statistics for the effects of a kind of treatment or teaching or instruction or something like this, and uh, uh, compare actually these two trends. For example, in this data set, we can see that the experimental groups measures after doing the treatment is increased highly and is somehow steady at the follow-up measurement. But the control group in a red line has steady measures with some equal means during the experiment. Or you may want to ignore the follow-up and do the covariance analysis and just doing the effect of treatment and control for the effect of the covariant measure that is for the pretest variable. For the in the experimental method, we have so many different designs for experimental methods that it's actually limited in behavioral sciences. In the field of statistics, there are so many complicated experimental research design that includes so many variable design for experimentation. But some kind of design like this with a control and experimental group, either it is true experimental with random assignment or would be a quasi-experimental with the non-random assignments of the subjects with the experimental and control groups. We may have some kind of analysis like this with follow-up or without follow-up. We have also um, actually emerging with the software like the R software. We have also some design for single subjects. We may want to split the experimental design to experimentation with groups of subjects and experimentation with single subjects. Experimentation with single subject is also developing in the last decade via R software and packages like SST4R that do the analysis of variances and the statistical inferences that's relevant for experimental design, supposing that the behaviors of a subject is a sample of instead of the measures from different subjects in control and experimental design. So, for example, in this example, you can see that measurements in three different phases are actually implemented during 20 weeks. For example, for a dependent variable like crying, or like baby crying, and this is the baseline. As you can see, this may be A, the baseline, the B after treatment, and the for example A for follow-up, ABA design, and this is an analysis of variance like the traditional ways that we do for a group of examinees are done through these software package like SST4R that do the single subject design analysis. So you can do your research or treatments, especially in fields of psychology and counseling, that you are dealing with single subjects and you are actually treating patients and clients. So these kind of design single subjects are so useful and relevant for practitioners in psychology and counseling. For non-experimental design, I would rather to uh, uh, divide it into some major design, like a survey design that is actually a major research design that is called for so many design in social and behavioral research. So in the field of statistics, it is preferred to name all of the design that we do in a cross-sectional manner, the survey design. But in the behavior research methods, we may name the variations of this research design, for example, to correlation design or survey in a different research design. But I would rather to uh, um, summarize this research design into the survey design, the correlation design that I would replace the correlation with relation because of some reason that I'm going to say, and the psychometric methods design that is something new because it is commonly supposed that psychometric design are a tool for constructing measurement instruments in psychology and education. But not only we can suppose this research design to do the measurements and for investigating validation of the measurement instrument quantitatively, but also this research design have some unique topics that is actually embedded in the field of psychometrics. So for survey design, it's common that you mm, do some analysis through surveys. For example, in SPSS, you have some sample data that is for surveys. For example, if you go to the destination that you install SPSS, you have samples in different languages. For example, in English language, you have some uh, files for different research design. For example, for the survey, you have a data set called survey samples that is actually done through the Gallup Corporation in United States of America. It is actually implemented about 4 years and in between, and measures so many social, psychological, economic, political, media, and other aspects of the attitudes of the people about their country. For example, you may want to investigate through chi-square, for example, what's the state of the happiness of marriage, for example. If you uh, analyze this variable for happiness of marriage that is measured in 3 categories of very happy, pretty happy, not too happy, and do the analysis for these, you can see that the very happy is actually and significantly more than not so happy, the happiness of marriage, when actually the marriage happened. It's not in the relationship like marriage. So you can find out uh, how marriage works among couples in the United States. You can do the same analysis for quantitative variables through one sample t-tests and SPSS. The other variation is actually the correlation research. I would rather to name it relational research because it's not limited to the correlation or some kind of analysis that is based on correlation matrices or covariance matrices like structure and cohesion modeling or multi-level modeling, but also it is including the multivariate discrete analysis that is going to analyze the relationships between the discrete variables. For example, you may want to network the relationships between some nominal variable, for example, happiness of marriage, the gender, the race, or other demographic and behavioral variables in a network. So we cannot confine actually the networking and the relationships or the path modeling of variables to the continuous variables. So the discrete variables are also included in some network analysis that we can investigate the relationships between these variables. So I named this variation of uh, uh, actually quantitative research. I call it actually, I name it the relational research. You can do the correlation and regression methods that is actually uh, so traditional, and mm, the direct relationships of two variables and more than two variables would be the one actually dependent variables investigating this kind of variables. But in more than 90% of situations, the the theories that you are going to investigate requires that you investigate the indirect analysis. So some traditional research method design like multiple regression design are not enough for doing the analysis. So some uh, uh, software like a smart PLS, as you can see on this demo, do the analysis through the direct and the indirect effects. For example, we want to know whether the quality of the services of a corporation is affecting the loyalty of the customers through mediating the satisfaction of the customer or not. But also we can actually investigate the direct relationships of variables in the conceptual models that we do, for example, in a smart PLS, that we are, the main objective is to uh, testing some hypothesis about the direct and indirect relationships of variables in the theory. But for theory testing, actually, this kind of modeling is not so relevant. So software like Listral is appropriate for theory testing when you have a solid theory. Uh, yes, you have a solid theory that needs to be tested. The Listral uh, software is appropriate because it actually yields you some goodness of fit measures that uh, uh, assure you that the theory is happening in real world or not. So the whole model is actually important in so many research articles or dissertations. So software like Listrel or AMOS or even R can do the actually covariance-based or correlation-based analysis through maximum likelihood estimation methods that Listrel and AMOS and software like R uh, do for you and provide with you some goodness of fit measures that are appropriate to test whether the theory is actually happening in real world or not. So the goodness of fit measures are measures for the validity of the model, and the model or conceptual model is actually something that is derived from theory. So when your main goal is theory testing, uh, structural equation modeling that is based on covariance and usually done through the maximum likelihood estimation methods are appropriate for your research aim. Uh, all of these relational methods are actually limited to measurements in a single level. For example, when you want to uh, investigate the relationships of variables in a bivariate or multi-regression or even in a structure equation modeling that not only investigated the indirect relationships but also can control for measurement errors and employ some latent variables in your models, as we do in a software like Listrel and Smart PLS. Uh, but there are all the same limitations that these models are confined to the measurement in a one level. For example, in an educational context, you suppose that you have students, classrooms, you have students that are nested into classrooms and classrooms that are nested into schools. So you have a hierarchical design that variables are from different levels of measurement. For example, the classroom, for example, the student level measured variables, the classroom levels of measurement, and the school level variables. So uh, in real theories, you have relationships between variables from different levels. So because of this limitation, uh, you have to ignore some of these variables or measure them in an irrelevant uh, level of measurement. For example, you may measure a student variable from the attitudes of a teacher that is in the classroom level. So uh, a relational model is developed that is named multi-level modeling method, that we do it using the R software. For example, uh, package like LMA4 do the multiple regression uh, analysis in multiple level. So you can do the multiple regression analysis in different levels. For example, you may want to investigate the variables from the level of school and classroom on the dependent variable from the student level, like achievement. Okay, or even there are some improvements that can combine, actually mix the multi-level and structure cohesion modeling together and do all of the analysis together through software package like Lavon that in recent years it is claimed that you can do the multi-level SEM or multi-level structure cohesion modeling through the Lavon package of R that do the latent variable analysis, and it is including the multi-level analysis. So combining these two research methodologies that we actually uh, nested these two in the relational research method design can yield you a research design a relational research design that is very powerful to investigate theories. There is actually no limitation for uh, investigating the relationship between variables, whether it is a latent variable or it is an observed variable. The direct relationship is important or the indirect relationship is important, and whether it is in different levels, for example in an educational context or in organizational context you have multi-level design. So this kind of design actually remove all of the barriers for investigating the relationship between variables in theory. As I said, the relationships of variables are not limited to the continuous variables. There are so many times, for example, in survey design that you are dealing with some discrete and nominal variables. There are uh, situations that you have to investigate the relationships of variables in direct and indirect manners for some single indicators that is measured in a nominal measurement scale. So you need to investigate this kind of relation. For example, uh, referring to the survey uh, data set, survey sample data set that is available in SPSS. You may want to, for example, investigate the relationship of some discrete variables. For example, I'm going to investigate the relationship uh, of the variable of gender and uh, let me say sex or gender, the marital status, and the dependent variable would be belief in life after this. These are three variables that may form some networks, for example, combination of two variables, combination of three variables, and the single variables are actually uh, the hypotheses that are going to be tested in this simple model, including three variables. For example, for the sex, we have male and female in a range of 1 and 2. We have a marital status in 1 married, 2 without, 3 divorced, 4 separated, and 5 never married. So we define range here to 1 to 5. And believing life after death is actually measured in a yes or no question. So the range is 1, 2. When you use some models like backward elimination, actually the process of discrete multivariate discrete analysis are automatically done through SPSS, and if you simply press OK, you are going to have a step summary that in the last step tells you that the combination of two variables are significant. The relationship between sex and marital status. It's it shows that being female or male is related to being married or being single. And sex and belief in life after death. For example, in this case, the result shows that actually females are less actually non-believers than men in this case that we use. So you may want to investigate some actually interactional uh, interaction of these variables through the standard residual. You can see that females here, if you look at the higher standard residuals, you can see that in females, non-believers in married are less than expected, and for singles are more than expected. So three-level interaction is actually observed here, and the whole model is actually fitted. If you want to find a fitted model or a valid model, we need to have a non-significant chi-square for the whole model, either in discrete multivariate discrete analysis or in structure equation model analysis. We have also psychometric methods using art. It is special for students in the field of psychometrics, and there are some research design that tells you not only you can employ measurement models for investigating the validation, investigating the validity of a measurement instrument in your research, but also you can apply these measurement models for some practical, for example, for investigating the test fairness. Actually, the test is just enough or not. It's a basic question that the test and the whole test and test items are not biased against gender, against races, against different languages. So test fairness is actually a special branch of the psychometric. We have also adaptive testing. We are when you are going to tailor a test for an special examinee, you need to do the adaptive testing. Actually, the adaptive testing is dealing with constructing a test that using a less lengthy test measure the ability in a more precise manner. So you can do the adaptive testing. It may be computerized or non-computerized. In this field, the computerized adaptive testing, actually the artificial uh, way that is actually is a trend for adaptive testing, using computerized adaptive testing through the measurement models. We can use computerized adaptive testing that is dealing with uh, item banks, item selection, item exposure, and estimating the ability of the examinees in a very automated manner through computer. We have also test linking and quoting that is about whether we can compare two scores from two groups of examinees and either some design to test examinees in a manner that we can compare their scores in a trend or not. For example, in Iranian uh, national examination, we are going to consider the final examinations for selecting them, for entering them to the universities. But we actually don't know whether these tests are the test score are a quota or not. So there are no actually designed for these tests that can be quoted, or the test scores can be linked together to compare examinees from different years. So it's actually solution for uh, the education ministry to actually use the final examination scores for the national concours examination. There are also some methods that are very new and based on the machine learning methods that can be also used in quantitative research. Actually, machine learning is not limited to computer science or something in robotics. You can do the quantitative analysis through machine learning algorithms that are more accurate than the traditional statistical methods. So we can see that using some software like Python and uh, some uh, features like Notebook, Jupyter Notebook can help you doing the coding for doing the machine learning analysis. For example, in this case, we are going to cluster our examinees. We are going to investigate whether our examinees are clustered in different clusters or not. For example, doing the non-supervised machine learning methods like the hierarchical methods, we can do this analysis and we can find out whether our examinees are clustered in different clusters or not. In this case, we can suppose that our, for example, um, uh, respondents or our students or our uh, measures, whatever, it's maybe a client, maybe a student or whatever, are actually clustered into some distinct clusters, or they are uh, actually hierarchically can be divided into different groups. So we can do our analysis through the machine learning algorithm. So the major difference of the machine learning methods and software like Python and R that do the analysis is that your variable is not limited to the psychological and educational measurement. You can do this analysis with everything, literally everything. You can do the analysis for images, you can do the analysis for voices, you can do the analysis for text. So, for example, in the era of virtual spaces, you can find big data uh, in text formats that yields you some information that are not available for example, in the traditional ways of educational psychological measurement. So, because actually people are exposing themselves in virtual spaces, so they are yielding some kind of information that is actually lacking in another situation. So, uh, the machine learning methods is actually opens you new windows for doing research in the field of educational, psychological, behavioral, and social research, because using actually analyzing text, analyzing image, analyzing voices, everything like a human, because that's why we call it artificial intelligence, because like a human that have so many senses, well, this method also uh, sense so many different variables, including the measurement that is done through numbers, or even it may be text, it may be image, it may be voices, videos, everything. So uh, there are some new books that uh, introduce you the use of data science in education, in psychology, or big data in cognitive sciences. Actually, the cognitive psychology and cognitive sciences are using this software to answer their question and to do the cognitive modeling in a significant different ways. These are actually the quantitative uh, methods that I'm going to talk about. So when I say the quantitative methods, I mean this kind of method. So it's not limited to a single research method books, even in national, international, because some research method textbooks are actually limited to some design and software that's like from 30 or 40 years ago. Then there are so many different and modern technologies and methodologies are emerging, like AI, like machine learning, and we have to adapt ourselves to these new methodologies in the quantitative realm of research methods. We have also the qualitative research methods. We uh, actually there are different softwares uh, available for doing the analysis, but I would rather Atlas TI because it actually supports the Arabic and Persian fonts, and you can easily do the analysis and the qualitative actually data analysis, and your design or research or qualitative research design may be uh, any design. For example, some of the well-known qualitative research methodology design includes, for example, phenomenology, ethnography, content analysis, comparative research, discourse and conversation analysis, theme synthesis research, narrative research, focus groups, action research, case study, and design that is a general design like descriptive qualitative research. The consensus about the qualitative research designs are not the same for the quantitative ones based on the fields of study and based on the researcher that introduces the methods. The actually design and the steps are different. These are actually based on the experiences of researchers that did the qualitative research design. So it's not weird that to researchers explain a qualitative research design in different manners. So because these are actually based on the experiences of the researchers. But softwares like Atlas TI provide you with a computer technology that help you to actually analyze the data. You know that the major difference between qualitative and quantitative research methods is about the data analysis. The data analysis actually in quantitative research method is done through the statistics and through the software. But in the qualitative research methods, the analysis, the basic analysis is actually done through your mind and your judgment. So this kind of software help you to analyze variables in a for example ways that your mind can do this through. Actually, it is generally recommended that you employ QDA or actually computer-based qualitative data analysis, because not only it can help you to organize your coding and your themes and make your life actually easier through this software, but also this kind of software doing the analysis by itself, that your mind can do this by your own, because even in some limited, for example, interviews, you cannot do some kind of analysis that for example, the query tool do for you. For example, in the query tool that the Atlas TI do for you, provide you with some operators that called set operators, semantic operators, and proximity operators. These kind of operators help you to look for example, the communalities of the codes and quotations, or the semantic operators provide you with the levels of and the ways of the relationships of the codes and quotations in your documents. That is actually your qualitative data. And the proximity operators actually provides you with some kinds of analysis that help you to search for some patterns. For example, is a code is actually co-occur with other codes, or is a code is actually within some code, or a code actually follows by some code, or precedes by some code. These are something that when you actually employ this software, you find the difference when you do not use this software, because your mind cannot investigate, for example, even in a limited number of interviews, whether a code is actually followed by other codes, and how many times it actually uh, mm, happens in your qualitative data. So not only qualitative data analysis software help you to do that, but also provide you with not only help you to code, to actually do the thematic analysis, and help you through some networks to do your analysis and make it easier, make it more organized, and help you to find out whether it is theoretically saturated, or it is actually uh, saturated by the sample that you are investigating. But also uh, through some analysis tools like the query, or other tools in analysis like code document table, uh, co-occurrence table. It actually help you to analyze more than something that your mind can do, and moreover, it can be done through more than one coder, and enable this in a intercoder mode, so you can actually investigate the reliability of the coders that some researchers, qualitative researchers like Silverman believes that uh, you should have some kind of internal consistency in your coding. So enabling intercoder mode can help you to investigate the reliability of your coding, and it actually make your qualitative research more organized, more systematic, or more academic than some kind of philosophers believe that qualitative research should be uh, in a, for example, philosophical ways, in a narrative ways, or something like this. At the end, we actually have the mixed research design that provide you with some uh, design that mix actually mixing some steps, the qualitative and quantitative design, and mixing them to look at the research problem in a more in-depth way, and in multi actually landscape way actually. So triangulation design or conversion design, actually the quantitative and qualitative research design are uh, actually run simultaneously, and the data mixing together and the interpretation is done. But in explanatory and exploratory design, uh, uh, actually the quantitative and qualitative research design actually are sequencing. For example, in explanatory design, we have first quantitative research design, then we have qualitative, and in exploratory one, we have first qualitative research design, then quantitative one. And we have some more complex design like embedded design, that, for example, a qualitative design may be embedded or nested in a quantitative design. For example, in an experimental design, you may want to have a case study design for example, in an educational context, a classroom may be investigated as a case study through the process of doing experimental design. Because the time is up, I'm going to finish it up soon and welcome you if you have any question. Do you have any question? Please, doctor. We welcome you. Mhm. Using software in qualitative research. Mhm. Uh, this is a misconception that is about computer software for doing qualitative data analysis. Actually, in quantitative data analysis, we are not actually converting codes to numbers. We actually do the coding in a software with in a way that we do in by hand in your, for example, paper sheet. Okay. For example, look at this document. We have some uh, interviews here. Hmm? This is the case. This is a qualitative research that is investigating the relationship between having children and happiness. It is going to study whether having or not having children is related to happiness or not. There are so many different qualitative data, including, for example, articles, for example, some videos, images, or proverbs, and there are also some interviews actually done here that ask from the respondents about the reasons for having children and reasons for not having children. These are actually based on the research questions. As you can see, that the codes here are something that is done uh, actually written on your text, like the way that you do on your paper sheet. So it actually facilitates the process of coding. It's not going to convert the codes to numbers. So uh, the thing, the analysis that after do the software is going to do the multivariate discrete analysis through these codes. We know that the way that computer deal with this code is converting it to the numbers, so it can do this through these uh, 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 through the numbers, and because the algorithm actually use the numbers for doing the analysis, but you can't see the numbers. It's just use the codes, the quotations, and you cannot see any kind of numbers in Atlas TI, in Max QDA, in NVivo. So it actually facilitates your coding and then do some kind of analysis that you cannot do uh, through your personal judgment. Hmm? Mhm. Mhm.
and it can classify it and do rational way, not for my mind, you know. It's not qualitative. It's not dependent to my description, to my
Mhm.
interpretation.
Mhm.
It's quantity, you know. It can
You are talking about using AI
yeah,
in analyzing text. As I said, AI-based methods. That is, for example, uh, it is about the large language models that is in the field of
text mining.
natural language processing or text mining or like that. These are basically quantitative models, and these are basically are based on large language models. But the way that you employ the software is not about employing AI to do the analysis for you. Although there are some algorithms in this software that is actually uh, actually built upon English language, not Persian language. So it can do the sentiment analysis, for example, for you based on some large language models. But the basic process of coding is not done through the AI. Is it is done by your brain. Using AI for text analysis is there are some language models, some algorithms that are built based on the NLP algorithms or large language model like BERT or LLM or something like this. These are doing some special kind of text mining, for example, sentiment analysis, for example, topic modeling, or some kind of, for example, bots that are based on NLP that um, actually analyze your text and answer you. So these are not about qualitative data analysis. Qualitative data analysis that is based on the researcher, researcher's judgment is more intelligent than the AI that right now we are using. So,
Quantitative research, for example, as you said, is based on researcher mind, you know. But AI can classify it better, you know. For example, it don't have any bias, you know.
mhm,
It will analyze it based from many data and many information.
yes.
And I think sometimes it's better, you know, it's better than
So,
my
well, yes.
brain, my mind, and my
It's,
interpretation.
it's a question. You
Yeah.
you can define some thesis dissertation about this, whether AI do the text analysis better than human analysis or not. And based on your experience, the AI analysis is better than the text analysis that human does. Okay, very good, very good. Any other question?
Another question is what's your prediction about using AI in research question analysis? You know, for example, now this, sometimes I send my score to my point to AI and I say, please give provide color analysis for this numbers.
Mm,
And we
yes. Mm, mm.
and what's your prediction about it?
My prediction about AI that it is growing exponentially. We are actually have some robots to do works in your home. So I predict that I heard a news about a class in a university in London that actually managed by ChatGPT. The ChatGPT actually taught the students in college for the first time. So we predict that we all should be equipped with the science of artificial intelligence. Actually, if you don't know the AI and the way the AI work, and you cannot utilize the benefits and assets provided with this kind of new technology, you will be faded soon. But if you can actually employ AI with you in your work, in your research, you can actually, your productivity is at least 100% more than when you lack it. Actually. Very good, very good. Thank you for having here. And thank you very much. Mr. Farooqipur, do you have any question?
No, thank you. It was
You are
very good.
welcome. You are
Have a nice
welcome.
day.
And bye. Goodbye. Have a good day. خیلی ممنون آقای دکتر. خیلی آقایان زنده باشید. خداحافظ. زنده باشید.
طول شما یه سوالی پرسیدم آقای دکتر ببخشید.
خواهش
خیلی جالب بود.